Okay, topic inverse functions. Make some notes, and when you're ready, click play again. So let's have a look at this function h of x, which is equal to 2x squared minus 7. X has got to be greater than or equal to 0. Now, if I start with x, and I want to get to this function 2x squared minus 7, first thing I'm going to do, I'm going to square that x function. When I square it, I get x squared. So we're getting closer. Then what I do to this is I'm going to times it by 2, which will give me my 2x squared. Getting closer again. And then to get to 2x squared minus 7, I take away 7. And I end up with 2x squared minus 7. So if I can just draw these oblong shapes then, showing where they belong to, and one more. Now if I want to get the inverse, if I want to go back all the way back to here, starting with x, this time the inverse of minus 7 is to add 7, so I'm going to add 7 here. That takes me to x add 7. The inverse of multiplying by 2 is dividing by 2, so I do that here. Divide by 2. It's the inverse of timesing by 2. So I get x add 7 divided by 2. And to get the inverse then of 2x squared minus 7, instead of squaring, I square root. And that gives me the square root of x add 7 over 2. So the inverse function h to the minus 1 of x of 2x squared minus 7 is given by the square root of x add 7 over 2. Just thought I would give you a visual depiction of that. Okay, right, moving back then, some notes for you to take. So the functions then, f of x and f to the minus 1 of x, are inverses of each other. And if you apply the function f of x to f of minus x, you get x, because they cancel each other out. You first apply the inverse function, then you apply the function, and you end up back with x. Similarly, if you apply the other way around, the inverse function to the function, you get x. So those are some notes for you to put down. So write those down, and we'll move on to have a look at an example. When you're ready, click play again. In addition, if we look at the graph of f of x and f of the inverse function, f of minus 1 of x, if we draw them, we can see then their reflection in the line y equals x. So f of x is the reflection of f to the minus 1 of x, and vice versa. Okay. What this means is that, and this is very important, the domain and range of the original function become the range and domain of the inverse. Important notes to make. The domain and range of 1 become the range and domain of the inverse. Oops, there we go. Okay. A few more notes for you. Inverse functions only exist as one-to-one functions. You cannot have a many-to-one function like a quadratic, because if you inverse it, it becomes a one-to-many, and a one-to-many is not a function. So inverse functions can only exist for one-to-one functions. So we want to write that down. If we graph our quadratic, its inverse, like such. and it cannot exist then because the inverse is a one-to-many. Okay, any value of x will give you two values of y. We can't have that. So your notes will include this section. Okay. Example. Find the inverse of the function f of x is equal to 3 over x minus 1. X is in the reals, so I can take any value on the number line, but x cannot be equal to 1 because that doesn't exist. So it wouldn't be a one-to-one function. So if we're looking at f of x equals 3 over 1 x minus 1, if we want to find its inverse, we've got to make x the subject. So we've got y is equal to 3 divided by x minus 1, and the aim is to make x the function. So we can cross multiply the x minus 1 and the y, so that gives us x minus 1 is equal to 3 over y, and x is going to be equal to 3 over y plus 1. Now, this is our inverse. We have to change the parameters because we want to write f to the minus 1 of x. That's going to be equal to, because it's x, is 3 over x plus 1. Okay. Here's another example. We've got this function f of x is equal to the square root of x minus 2. X is in the reals. X has to be greater than or equal to 2. We've got three things to do. State the range, find the function f to the minus 1 of x, and state its domain and range. And then we've got to sketch the function and its inverse. And we're going to draw the line y equals x so we can see if it's a reflection, which it should be. So if we take part A first, two ways of doing this. Part A. If I look at the function here, it says x has to be greater than or equal to 2. So it starts from where x equals 2. If I draw a little sketch here of my x and y axes. So from about here, say, where x equals 2, those are the values of x it can take. Now if I sub in when x equals 2, the function f of x is going to be equal to 0. From there though, any value I put for x, it's going to be bigger than 2, so it's going to start to grow. If I put 3 in there, it's the square root of 1, which gives me 1. If I put 10 in there, it's the square root of 8. Say I put 18 in there, square root of 16. So it starts to grow. Now I know my my square root function looks like this. So it grows unbounded, grows towards infinity. So if I write that here, y is equal to square root of x minus 2. It's minus 2 because that point is there too. If you remember from our graph transformations, the square root of x would start from the origin. So that means the range then is given by y is going to be greater than or equal to 0. It starts from 0 and grows unbounded. So that's part A. For part B, I need to find the inverse function. Now the inverse function is given by making x the subject. So I've got y is equal to the square root x minus 2, square both sides, gives me y squared is equal to x minus 2. And so x is going to be equal to y squared plus 2. So changing the parameters then, f to the minus 1 of x is given by x squared plus 2. And finally, I've got to sketch y equals f of x and y equals f to the minus 1 of x and the line y equals x. So if I sketch that here quickly, as best I can, doesn't seem to be a ruler in PowerPoint. So that's my x, that's my y. Now we've already sketched the square root of x minus 2. That goes like that. That's point is 2. That's y equals square root of x minus 2 or f of x. Then, now, my inverse function is x squared add 2. Now, x squared, quadratic, starts here. It's a U shape. But because it's plus 2, it's going to start here at 2. And it goes like so. Now, the inverse function has a range and domain, which are the inverse of the function. So its domain is the range. So that's going to be given by x is greater than 0. And its range is the original domain. Y is greater than or equal to 2. Which is why it starts at 0 and grows unbounded there. And if we draw a y equals x line, see if I can do a dotted line through there. There you go. This is f, the inverse function here. So hit pause, make some notes. When you're ready, hit play again. I thought you might appreciate a neater diagram. There's your y equals x. There's your original function, y equals f of x, and there's your inverse function, y equals f to the minus 1 of x. Okay. Let's have a look at another example then. Okay, one more example. You got the function given by x squared minus 3. X is in the reals and x has got to be greater than or equal to 0. That's its domain. Find the inverse function, sketch the inverse function, state its domain, and then solve the equation. Right, so part A first, find the inverse function. Here we are. We've got y is equal to x squared minus 3. We've got to make x the subject, so as x squared is equal to y add 3. So x is going to be equal to the square root then of y add 3. So the inverse function is given by changing the parameters, the square root of x plus 3. So that's part A. Let's quickly have a look at its at the original function, part B. The original function, f of x, is given by x squared minus 3. Its domain, x is greater than or equal to 0. Its range, well, it starts when x is greater than or equal to 0. So when x is equal to 0, the function is equal to minus 3. And anything else then takes it bigger, so that means the function is going to be greater than or equal to minus 3. 0 gives us minus 3. If we add 1 here, it will give us minus 2, so it grows from there on. If we look at the inverse function, f to the minus 1 of x, by definition then, which is equal to the square root of x plus 3, its domain is going to be the range of its inverse. So that means x is going to be greater than or equal to -3, and its range, f to the -1 of x, is going to be the domain. So it's going to be greater than or equal to 0. So it's handy having the inverse function, because all you do is you just flip the domain and range around of the original. We can sketch that. And I tell you what I'm going to do. I'm going to use the PowerPoint sketch because it's neater than mine. So hit pause, make some notes, and then when you're ready to have a look at the PowerPoint graph, hit play again. So there's our inverse function, square root of x at 3, and that's what it looks like. You can remember from graph transformations, square root of x would start at the original curve, but because it's add 3 within the function, we move it along to the left hand side 3. Now the original function is x squared, but it's -3, so it's x squared -3 moves it down the y-axis 3, and we can sketch that going up then. And if we draw our line y equals x, you can see that they are mirror lines of each other. From the graphs we can see that the function f of x and its inverse, they intersect on the y equals x line here. So we can say the function is equal to x squared -3 equals x. Rearrange to give us x squared minus x minus 3, and then we solve then to give us the values of x. Now the factors of 1 and 3 won't allow me to factorize it simply, so I'll have to use the formula. A equals 1, b equals -1, c equals -3, and then using the formula, which you guys are quite happy to use on the calculator, we get x equals 1 plus the square root of 13 over 2. It's going to be positive, because if we look back at the graph, the solution is a positive one, not a negative one. So it's going to be just the positive solution we take from that. Good. So make some notes, and when you're ready, I've got some questions for you. So we've got exercise 2D on page 38 and 39, 12 questions. Off you go, good luck.